Hi class. In this video, we're going to go over setting up the DMZ DNS properly with the web server so you can see how the DMZ functions. And then we're going to go into covering how all these DNS servers work together. So I have two eDNS servers, two internal DNS servers, then I have some DNS servers out on the web. But before I get into that, I wanted to kind of cover the time sync issue. I intentionally left my machines running overnight without shutting them down. And when I bring them back up, everything is out of time. So I ran this command right here to sync this server against the time clock on the internet. After I do that, I'm going to reboot DC1. If you don't have that command, just rewind the video so you can see this command right here. I'm running this on DC1. Because you don't know this yet, but DC1 is my time clock for the entire network. And then I'm going to run this time to resync it. So once this machine is resunk, I'm going to go to DC2 and reboot that one. So to avoid this issue, make sure you shut down all the virtual machines at night. While it's rebooting, I'm going to pause the video. So if you now compare this time to the clock on my real machine, you can see both of my domain controllers are synchronized as far as time. If you don't have a synchronized time, clients might not be able to communicate with each other or the DCs. So it's important that you have your clock synchronized, especially on all the machines that are domain control that are joined to the domain. And all these eventually will be joined to the domain. These three machines and the NAT router won't be part of the domain. We don't want the NAT router to be part of the domain because it touches the internet. These three machines are going to be in the DMZ, and we don't want these to be in the domain because if they get hacked, we don't want anyone to be able to access any domain resources. So these two machines and all the machines we haven't configured yet will be part of the domain. So right now I have the NAT router up and running, DC1, DC2, eDNS1, eDNS2, and the web server. So the first thing I'm going to do is sign into eDNS1. And sign into eDNS2. If these machines are out of sync, it's no big deal because they're not joined to the domain. I'm going back to eDNS1. You can try the resync command to see if that works, but it's not a big deal. And it worked. That issue is an ACE-IT issue. It's not a Windows Server issue. In real production networks, your machines don't go to sleep at night. They stay running all the time. Just to be able to share resources with all the students, we have all the machines hibernate at night when you're not using them. So we're not using resources up that other students might need. So this is an ACE-IT thing, not a real production network thing. This time is too far off, so this one has to be rebooted. Okay, so while that's being rebooted, when we initially set this up, I was using it as a practice machine. I wanted to show you how to set up forward and reverse lookups and how to set up records without really going too much into detail about the DMZ. But these aren't configured properly for the DMZ. So what we're going to do is wipe these out and then reconfigure them properly for DMZ. And as I go along, you'll understand. So I'm going to delete contoso.com. I'm on eDNS1 and 17172.inadder.arpa. So up until this point, I've explained to you that the machines that are going to use these DNS servers are machines out in the internet. So we're going to resolve all the IPs to public IP addresses. So I'm going to go to my NAT router. I'm going to sign in. I'm already signed in. So I'm going to go to local server, and click on any one of these interfaces. Then go into my public network. Then double click on IPv4. Once you're in here, click on Advanced. In a real production network, corporations have multiple public IPs. Let me pull up the map. So in this interface, when you contact your ISP and order your internet connection, most corporations get multiple public IPs. So this interface is going to have multiple public IPs. So we're going to pretend our 10 address is a public IP. So what we're going to do is we're going to add several IPs. So I have 2 through 5 so far. I'm using 24-bit subnet mask on all my IP addresses. So I've assigned multiple IPs. 2 through 8. I click OK, OK, OK. If I double click again and go into details, I can see I have multiple IP addresses assigned to one interface. And you can pretty much do this with any computer. If I go into the command prompt, I can see those multiple IPs here as well. Okay, so our gateway is .1. That's the next router in line. If you look at our diagram, that's this IP over here. That's not controlled by us. And our ISP has given us 2 through 8 public IPs. So what we're going to do now is we're going to associate one of those public IPs with this interface, with this machine. We're going to associate another public IP with this machine, another IP with this machine. What we're doing is something called NAT, Network Address Translation. So by default, when a computer from your internal network needs to request data from the internet, it's going to send it to the NAT router, and as that packet traverses that NAT router, goes from this interface to this interface, we've labeled this interface as NAT. So basically, we're telling our computer that every time a packet from inside here or inside here traverses the router and leaves this interface, we're going to pull out the private IP. In this case, the private IP is 172.16.0.3, and we're going to place it with one of our public IPs, then send that packet out. So when the web server out in the web responds and sends the packet back, it thinks it's talking to that client when it's really talking to this NAT router. So this NAT router is going to receive that packet, and it's going to have something called a NAT table. It's going to look in the NAT table and pull out the public IP, put back in the private, then route it back to the client. So as the client communicates with some server on the web, it's going to go out this interface, it's going to go across, and at this interface, it's going to pull out the private IP and actually the port number as well, replace it with a public IP and port number that's free on this NAT router, then puts an entry in the NAT table saying that this port number, this public port number I'm using, is associated with this private IP and this private port number, and then send it out. When the response comes back, it will do the reverse. It will pull out the public port number and the public IP address, put in the private port number and the private IP address, then send it to that client. So any internal client, whether it be from here or here, will be allowed to request data out, no problem. So if some client out on the internet tries to connect to one of these servers, all these machines are invisible to any machine on the internet, because the only thing that computers on the internet will see will these public IPs, because by default, NAT only works one way. When you send a packet out, uh, the response is allowed back in. But if someone tries to initiate new traffic out on the internet to this NAT router is going to drop that packet. Unless we do something special called port forwarding or IP forwarding. What we're going to do is IP forwarding, NAT versus PAT. So we're actually going to do true NAT right now. So if you've ever opened up a gaming port at home, that's what we're going to do. We're going to open up some ports, some IPs, and associate them with these IPs here. So when traffic comes out from the internet, new traffic comes out from the internet to this interface, this router will send that traffic to one of these three machines. So we've added the public IPs. So now we're going to go to Tools and open up Routing and Remote Access. So on our NAT router, we're going to go to our server, IPv4 NAT. Guys, be careful. Don't go down into IPv6. Go to IPv4 NAT, then highlight your public interface and go to Properties. We can see that this IP has the NAT feature turned on. This interface has the NAT feature turned on. So that lets the computer know when a packet comes and hits this interface, it's supposed to be doing NAT, pulling out the public IP, putting the private, or vice versa. So we're going to go to the Nat Pool, and we're going to add all of our IPs, all of our public IPs that were assigned to us. So what we paid for from our ISPs is IPs 2 through 8. So I'm going to click OK. So our NAT is now aware that it has multiple public IPs. So we're going to associate these private IPs, these public IPs with these private machines. One public IP is going to be associated with one private. Another public IP, another private. A third IP, another private. So basically, if this router gets any traffic to that IP, it'll automatically know to send it in to one of these three boxes. So if some computer on the internet initiates new traffic, normally new traffic isn't allowed in. Only a response is allowed back. But if someone initiates new traffic and we've opened up those ports or IPs, then that traffic would be allowed in. So some machine out on the internet, a DNS client, will be able to initiate new traffic to our DNS server, and our DNS server will respond. So we're going to make reservations. So we're going to associate 10.0.0.8 with 172.16.17.0.4. That's eventually going to be the private IP for this machine. And we're going to allow incoming sessions. So if some client out on the internet sends a packet, a request for a website to this interface, 10.0.0.8, this router will do nothing with it but send it into this box right here. This web server will then be able to respond and give out the web page. We're exposing this web server to clients out on the internet. Let's do another one. We're going to reserve 10.0.0.7 That is the IP address of eDNS2. We're going to allow incoming sessions. So if a client on the internet sent a packet to 170, excuse me, if a client on the internet sent a packet to 10.0.0.7, this machine won't do anything with it but send it into this machine. And the last one is 172, no, 10.0.0.6. We're going to allow incoming traffic. Essentially, new sessions. That's what it's asking. So basically, I've associated these three public ports with these three private ports. So if someone sends a packet to my NAT router to IP 10.0.0.6, that router is just going to send it in to eDNS1. If some client on the internet send a packet to 10.0.0.7, the NAT router will forward it in to eDNS2. If someone out on the internet send a packet to 10.0.0.8, I'm going to send that packet in to the web server. Okay, this is the last public IP. This is the next to last public IP. And this is the third from the last public IP. This is eDNS1, eDNS2, the web server. Click OK. So now we have our NAT router fixed up with multiple public IPs, and we forward in the traffic into our DMZ. I'm going to go over to eDNS1. So I'm going to create a new zone. It's going to be a primary zone, meaning a read-write copy, and I'm going to send it into Contoso. I'm going to have the name called Contoso.com. It's going to save all the data in a text file, and I'm not going to allow any dynamic updates. All records have to be manually created. No client will be able to connect to me and create records on its own. Finish. So just like every other NAT router that's not integrated in Active Directory, we have to manually create all these records. So I'm going to first fix the SOA record. Contoso.com is going to be the name of the primary server, and the email address for the responsible party will be hostmaster@contoso.com. You don't use the @ symbol though. When a human reads this, they'll know to replace it with an @. Then the next record we need to fix is the NS record. So it automatically creates one, but it doesn't complete it. So I'm going to fix that first before I create a new one. So the fully qualified domain name will be edns1contoso.com. And on the internet, that machine has an IP of 10.0.0.6. You don't want to use private IPs because the only machines that are going to use this DNS server are on the internet. So we're going to tell everyone our DNS server is right here. So which is 10.0.0.6. So when any computer needs to contact our DNS server, they'll send it to this IP, then this NAT router will send it into that machine. So we need to resolve my public name for eDNS1 to my public IP. So when a client out on the internet sends a packet to this router, it'll send it in. If we resolved it to a private IP, these private IPs can't be reached on the internet because these are all invisible. The only interfaces that are seen on the internet are the ones on this public router, on this public interface. So I'm going to click out of the white box, click OK. Now I'm going to add a second DNS server, edns2.contoso.com, 10.0.0.7. So EDNS2 is the public IP associated with EDNS2 is 10.0.0.7. So those are my two DNS servers. Now I'm going to create a host record for www. I want to resolve www to 10.0.0.8. That's the public IP that I've associated with that web server. So when someone on the internet contacts my DNS server and says, what's the IP for www.contoso.com? I'm going to give them 10.0.0.8. And then they're then going to send a packet to that 10.0.0.8. This router will send it into the web server. Then click OK. Normally, I'm just going to keep it simple, guys. So I'm just going to leave those three records. I'm going to highlight this, hit refresh. When I fix these NS records, it also fixed these records as well. So when I created these NS records or fixed them, it automatically added the associated A records for those names. Because an NS record points to a name. So when I fix that NS record and point it to that name, it adds a host record associating that name to that IP. So now we're going to fix our reverse. So I'm going to say new zone. Next, it's going to be read write. It's going to be a reverse lookup zone. And it's going to be 0.0.10. Again, these DNS servers are only handling people on the internet. So I'm going to put in my public network when I resolve IPs to names. I don't want to resolve private IPs to names because those clients can't use those private IPs. The clients will never have that private IP. Sorry, I needed a drink. Okay, so again, the private IPs, clients will never have them, so they'll never send me a request trying to resolve a 172.17 address to a name because they will never have that 172.17 address. The only IPs that they're going to have are these public IPs. So I'm going to create a zone to resolve all those public IPs to names. Next, all the data will be stored in a text file. No dynamic updates. Sorry, I hit the wrong button. Okay, so just like on the forward lookup zone that handles names to IPs, we have to do the same thing on the reverse, which handles IP to names. We have to fix the SOA record. So contoso.com, contoso.com. For the NS records, I'm going to edit the first one, contoso.com, and that has an IP address of 10.0.0.6. Then add a new record for EDNS2, www.contoso.com and give that an IP address of 172, nope, 10.0.0.7. Don't worry about that not working. You notice it worked fine when we did the forward. Sometimes it just doesn't work. Don't worry about it if it says not valid. Then we'll click OK. The next thing I'm going to do is create a pointer record for I'm not sure why it's not allowing me. Sorry, I did this wrong, guys. Sorry. I'm going to delete this. I went and reversed it manually when I shouldn't have. So I'm going to create a new zone. Primary read-write for an IPv4 network. I shouldn't have reversed it. I manually reversed it. I should have put it as 10.0.0. What I did was 0.0.10. I knew it was a reverse lookup zone, so I manually reversed it. It does it automatically. So sorry, we have to do this again. The SRA record. There's a bit of a lag. Then the NS record. And again, you shouldn't use any private IP addresses. You shouldn't have at any point see a 172 address anywhere in this zone. So I'm going to add a second one for EDNS2. .0.0.7. Click OK. So I'm going to create a pointer record for 6, and that points to edns1.contoso.com. So if you send me this IP, that's the name I'm going to give you. .7 will point to edns2.contoso.com. Then lastly, I'm going to create a pointer record for 10.0.0.8, and the host name will be www.contoso.com. You send me in this name, excuse me, if you send me in this IP, I'll give you this name back. You send me in this name, excuse me, when you send in this IP, I'll give this name. When you send in this IP, I'll give you this name. For the forward lookup zone, you send this name, I'll give you this IP. You send me this name, of course, it's appended to contoso.com. You send me this name, I give you this IP. You send in this name, I give you this IP. Our forwarders, I never set up yet. So I'm going to highlight eDNS. So if someone sends me a request to resolve, hold on 1 second, please. Okay, so if a DNS client points to this machine and tries to resolve the name www.contoso.com, I'll be able to give them an answer. But what if someone sends me a request to go, they want the name www.google.com? I don't have that answer because I'm not the start of authority for Google. So I need to talk to another DNS server. So that's what the forwarders are. I'm going to send any request I don't know the answer to to these machines. So I'm going to click Edit and do 8.8.8.8, tab, then 8.8.4.4. Then click OK. And I'll explain root hints in a little bit. They're kind of indicating right here, but that's fine for right now. So I'm going to click OK. And eDNS is now configured properly to handle clients on the internet. Initially, I set it up just to show you how to work a standard DNS. I didn't want to confuse you with public IPs. On this machine, my IP address is 172.17.0.2. It's not 10.0.0.6. But for people on the internet, that's what they'll see my IP as. They won't see this IP at all because the NAT router is going to send any traffic to this IP to this IP. That's what the NAT router does. If you've ever opened up a gaming port, we're doing essentially the same thing. So now I'm going to go set up eDNS2. Now this one is just going to be a copy, so it'll be real easy to configure because all I'm going to do is copy over the data from eDNS1. I'm going to go to Tools, DNS. The first thing I'm going to do is I'm just going to try to transfer from master. Then refresh. It didn't work. So I'm going to go to eDNS 1. I'm going to right click contoso.com. I'm going to go to Star of Authority. I'm going to set the serial number to 500. Then click OK. Then go back to eDNS2. Currently, eDNS2 saw the serial number as 11. So now when I do a transfer from master, it's not working. I'm going to try to transfer a new copy. Okay, I'm not sure why it's not working, so I'm just going to wipe it out and redo it. It should see the new copy, but it's not. So I deleted it. I'm going to create a new zone. Secondary. Contoso.com. I'm going to copy it from 172.17.0.2. Finish. Transfer from master. Oh, I know why. I'm going to go back to eDNS 1. I'm I'm going to right click the zone file under under zone transfers. I'm not going to say only servers on the name server tab because the name server tab is listing the public IP addresses. So for zone transfers, I'm going to say only to the following servers. I'm going to put in 172.17.0.3. Don't worry about that not being validated. So I'm going to click OK. Now when I do the zone transfers, it should allow me. Oh, it already did it. So I'm going to do the same thing for the reverse. I'm going to go back to eDNS1, go to Properties, then go to Zone Transfers. I'm not going to allow only the servers on the name server tab because they're using public IP addresses. I'm going to say only the following server and specify the private IP address, 172.17.0.3. Click OK. So I'm going to go to the reverse, delete this old test one we were dealing with, create a new zone, and again, we need to be a secondary copy, IPv4 network, and the network is our public network, not our private. And we're going to transfer it from 172.17.0.2. Next, then finish. Transfer from master, refresh. You might have to do that 2 or 3 times. Okay? So I'm going to pause the video for 1 moment. Okay, so now we're going to test it out. So I'm going to click on Start, Windows PowerShell. I'm going to do ipconfig all. Sorry. Guys, when you mess up a command, instead of retyping it, hit the up arrow, because you can use the up arrows for your history. ipconfig all. I can see that right now my DNS client has 2 IP addresses. It points to the DC1 and DC2 for name resolution. Sorry, I didn't mean to hit that. So the DNS server is going to handle external clients out in the internet. But the DNS client is inside my private network, so I need to point to internal DNS servers. So by default, my client is pointing to these 2 DNS servers. So when I go into NSLookup, it points to DC1. So what I'm going to do is I'm trying to test these 2 machines. So I'm going to point it back to eDNS1. If I send in the name contoso.com, that server, I'm right here. I'm using the DNS client on this machine. I'm connecting to this machine to resolve www.contoso.com. It sent me back the IP address. And that's the IP address that it sent me. So now I'm going to contact I want to resolve www.google.com. So I'm going to go back to my diagram. This DNS client contacted this DNS server to resolve www.contoso.com. This DNS server is not the start of authority for google.com, so it then connected to the internet to the IP 8.8.8.8 and resolve that to get that name resolved to an IP. That computer was able to resolve it. It sent me back the information then I forward it to the DNS client on this eDNS2. So it can handle both public and names that I'm start of authority for. So I'm the start of authority for Contoso.com. It can resolve those names. I'm not the start of authority for any other name, but I can still handle those requests. So now I'm going to test myself. 172.16, sorry, 17.0.3. So I'm going to have the DNS client on this machine talk to the DNS server on the same machine. I can resolve www.google.com. Maybe I can't. Oh yeah, it came up. And then I can resolve Contoso.com. So I can resolve some namespace that I'm not the start of authority for, and a namespace that I am the start of authority for. So I'm going to exit this out. Okay, the last thing we're going to do now is, just so we have something to test with, I'm going to show you how to set up a web server, a quick and dirty web server. This is the next available private IP for this subnet. This was 172.17.0.1. This is 172.17.0.2. This is 172.17.0.3. And this one is going to be 172.17.0.4. I'm using the default subnet mask, and the gateway will be their router. And again, the DNS client on this machine needs to point to a DNS server that handles private IP addresses, and I'll go over that. So I'm going to point to these two DNS servers. These two DNS servers don't know the private IP. They only know public IPs. So I don't want to point to these two DNS servers because they don't know private IPs. I didn't even point the DNS client on this machine to this server. I didn't point the DNS client on this machine to this server. The only machines that will use this server are for public requests. So I'm going to point to 172.16.0.2 and 172.16.0.3. You see how I missed that flyout? I guess it's kind of good that I missed it. Every time I connect to a new network, that flyout comes out and prompts me to relax my firewall or not. Because I didn't hit yes, I still have a public firewall. so my machine is locked down. I don't want that. So what I'm going to do is, if you miss that firewall, I'm going to show you what you have to do. I opened up Windows PowerShell ISE. And if you don't know the full command that you want, but you know part of the command, you can type in that part of the command that you know, and that's the command. So if you don't remember it, I remember that it had connection in it, so I'm going to do set net connection profile to network category private. There's no graphic way of doing it if you miss that flyout. This is the only way. This works in Windows 10 as well. Or you disconnect from that network, then reconnect. So I'm going to minimize this, go back here and hit refresh. And now it's private. I had to do that because I missed that flyout. Again, set network connection. The network category is private. All it does is when I go into Windows Defender Firewall with Advanced Security, by default, the firewall has three profiles: a domain profile, where your firewall is relaxed; a private profile for either a work environment or a home environment that's not joined to the domain. Again, the firewall is relaxed; or a public profile where the firewall is not relaxed at all. Everything is locked down. So when I said private, I'm using that private firewall profile. The next thing I wanted to do is set my computer name. Computer name and domain names are all lowercase. I'm going to pause the video while it's rebooting. Okay, it's rebooted. I'm going to sign in. Guys, I understand this is a large topic. It's a difficult topic as well. I'm going to wait till this blue bar goes across, and then I'm going to install the web server. Just like all the machines so far, we configured the IP address, we configured the host name. We're going to install some software now. I'm going to go down to server roles. Guys, incidentally, I just wanted to show you something. I could just click on that link and just jump down. I'm going to choose the web server. I'm going to include all the management tools for the web server. Click next, next. I'm not going to customize it at all. Restart if needed. And this time it won't restart. Click install. So once this is installed, it's going to create a new directory under the C drive called inetpub. I'm going to pause it while it's installing. Sorry, I jumped the gun and started pressing buttons before I started recording again. So it finished installing it and I click close. So now I can see on my C drive, I have an inetpub folder. So I'm going to create some simple content I can host on the website. I'm going to make a directory under, you see what I did there? No, you didn't see because you can't see my keyboard. I hit IN, then tab. Why didn't I have to type, why can't I just type that and not have to type in the C drive? Because I'm already on the C drive. So if I type IN, then the tab key, it'll auto-complete. It will even do it if I use the wrong slash. In Windows, the separator between directories is a backslash. In Linux, it's a forward slash. So Windows will understand the Linux method or the Windows method. So that backslash is the separator. So when I just hit backslash IN, it's saying the root of the drive that I'm currently on. So I'm on the C drive. So it's going to look for a folder starting with IN. Hit the tab key, and I'm going to put my site. So this command creates a directory, make directory. So all I did was in the inetpub folder, I made a directory called my site. So I'm going to echo something into inetpub, my site, then I'm going to type it index.html. So basically, I'm putting the word something in a file in the folder called inetpub, in a folder called my site. I'm going to create a file called index.html, and inside that file is going to have the word something. I'm just creating some simple web content. Basically, when you connect to a web server, it's automatically going to pass out this file. When you connect to www.cnn.com, you don't specify what file to give. As soon as you make that connection, the web server will know what file to pass you automatically. In Windows Web Server, it's called index.html. So I'm going to exit out of this. So now if I edit this file, I'm just going to use WordPad. I can see the word something is in it. Okay, so now I have some web content. I want to host that web content on my web server. So I'm going to go to Tools and choose Internet Information Services, IIS. By default, we have a default website. So we're going to create a new website. So I'm going to drill down until I see sites, right click sites and say add website. This name here is for this list. It has nothing to do with the name you're hosting it. So what we need to do is tell the web server where that file, where that folder is. All of your web content should go in inetpub. I'm going to choose that folder called my site. Inside of it, there's already an index.html. I don't need to specify index.html because that's the default file that the web server will pass out. And this website is going to be known as contoso.com. Click OK. So now this web server is hosting two websites. Okay. The default one, which is just like a sample page, and the one that we created. So actually, I'm going to do the next step in the next video. In the next video, I'm going to explain how all three DNS sets of DNS servers work together. My internal DNS servers that host all private IPs, my external DNS servers that host public IPs, and the internet DNS servers. They all have to work in conjunction with one another using your DNS clients and forwarders. So we're going to look at how people in the web, the internet, would get to this www server. I want to show you how people internally will get to this www server, by name, of course. So I'm going to stop this video, upload it to YouTube. Then the last video, I'm going to show you how everything works. I was going to do it in the live session tomorrow, but the problem is several people have contacted me. They can't attend the live session. So I'm going to make it a video and answer questions about the live session and re-explain it in the live session. So I'm going to put it on the video and also cover it in the live session. Okay, so that's it for now. I'm going to stop this video and I will see you in the next video. Thank you.